25th, we're going to be doing the specific heat, learning about specific heat, and doing a specific heat lab. 7.4 will be assigned today. No, I have been putting your lectures up on YouTube and then linking them here. I'm also going to start embedding them. So if you keep going down on the grid, they will be embedded so you don't have to get up on YouTube, so you can actually watch them here at school. So I just haven't figured out how to embed them within the grid. So that's why you have to go to the bottom. So if you want to see them, that starts last time's lecture. I'll start doing that with that. So we're going to do the lab today. We'll finish up the lab next time, do a review, and then test is the next day. So you can retake those quizzes on next time if you haven't got those done. So quiz 7.4 was what you're supposed to be working on today. The objective today is to use a specific heat equation to solve for desired variables. We're working with standard 4, 2F. And we're going to correct assignment 7.3 in just a second. We're going to do the lab and the lecture, and then 7.4 is due next time. When we go back to the lab, my suggestion is you bring your own calculator or one from me up here, and your assignment 7.4, because part of the lab is waiting for water to boil, and it's very boring watching water to boil. And most of the kids in first period were able to finish their assignment and get their extra point stamp for getting it done while they were back there. So that's a good use of time. Okay, so if you would take your assignment and pass, there are just a few notes, so we're going to go through those notes really quickly so we can get back to lab and you can work on problems. We're going to be working with, yeah, go ahead and shut the door so we don't have a wind tunnel. You weren't fast enough. Okay, so let's talk about specific heat. Specific heat is the amount of energy it takes, or amount of heat it takes to raise 1 gram of something 1 degree Celsius. Okay, so that's by definition what specific heat is. Specific heat, 1 gram of one substance, 1 degree Celsius. Metals tend to have lower specific heat because they get hotter faster. I don't have to put as much energy in and they get hot. Water has a very high specific heat, so when we go to our lab, it's going to take a while to heat that water up. Okay? So how easy or how hard an object is to heat up, or how fast does it absorb energy, is all about what specific heat's about. And we're going to be working with specific heat. Okay? So basically make sure you have down that it's the amount of heat that it takes to raise 1 gram of a substance 1 degree Celsius. That's what specific heat is. Okay, 1 gram, 1 degree Celsius.
What about to lower?
To lower 1, that would be how much energy would be lost.
Yeah.
It would still be working with heat, yes. We usually talk about raising it because it's easier to measure how much you put in than take out. Okay, so we're going to be working with this equation. You will see me write Q as a lowercase. It doesn't matter if you use lower or uppercase. You will see me write C as CP because that's just how I learned it. So let's define each of these. Q is if they ask for energy. Yes, ma'am? What's the definition of specific heat? How much energy it takes to raise 1 gram, 1 degree Celsius of some substance. Okay, so looking at this, it's color-coded. Hopefully that helps you. Heat energy is Q, so anytime they're asking for heat energy, it can be in calories. In SI unit, it will be joules. I should make that red. Remember, joules is a capital J, calories is CAL. Now, these calories that we're talking about here are lab calories. They're not nutritional calories. So if you see, oh, if I ate this substance, I'd get 180 calories. Those are actually kilocalories, what we call nutritional calories. Your body takes a lot more energy to work and run than a lab calorie. A lab calorie is a very small unit. Okay? So 1,000 lab calories equals a nutritional calorie. The M is mass. That's your blue, and it has to be in grams. Specific heat needs to be in calories per gram degree Celsius or in joules divided by grams degrees Celsius, but the Celsius could be replaced by Kelvin because the units of measure in Kelvin and Celsius are the same amount. All we did was add 273 to go from Celsius to Kelvin, so we didn't have any negatives or 0. Yes? Dropper bottles, the ones that we have, if there's any more left, would be in the cupboard that the still's on, down this way to the west, underneath, and it'd be in a big brown box if we have any left.
What about the bottles or dropper bottles?
So that's what I'm talking about, not the other that pick up, not the ones that have the micro pad on them, but the ones you squeeze. That's the other thing. That's in the big box. That's in the big box. It's a big brown box. It's underneath. Okay, so on the delta T then is a change in temperature. And the change in temperature, the delta just means change in temperature. The triangle just means change in temperature. That's temperature final minus temperature initial. That's what the F and the I stand for, is final and initial. So as we look at this, if delta T is negative, then we have what is known as heat loss, and Q is negative. If delta T is positive, then heat is gained and Q is positive. So if I have a system where one is losing heat and the other one's gaining heat, I can actually set them equal to each other and change the delta T so that they're both positive, because whatever's lost is going to be gained, and they can be equal to each other because they're opposite signs, and that's the only difference. And that's what we're going to be doing in lab. Okay? We're going to change that so that it has a positive delta T all the time. This one is not always positive as written. So then we're going to talk about exo and endothermic reactions. Exothermic, remember, is heat energy being released, and endothermic is energy being absorbed. So if we talk about, and this is just, you know, thinking about what we did before, we've talked about exothermic, we've talked about endothermic. The only difference is here, exothermic Q would be negative, and endothermic Q would be positive. Okay, so in our equation that we just did, Q equals mCp delta T. All right? Now, let's do an example. Most specific heat problems are story problems. Okay, so take yourself and start pulling stuff out. I hate story problems, you hate story problems. Just pull the information you need out. So, grams, that's a mass. So I'm going to put 38.8 grams as my mass. Piece of metal alloy absorbs this amount of joules. Joules is energy, so that is my Q. Temperature increases, so this is going to be with my delta T, increases from this to this. So my final temperature was 36.0 minus 25.0 will give me 11.0 degrees Celsius and change. Then it wants to know, what is the alloy's specific heat? Specific heat was the C or CP. Like I said, you'll see me write CP just because that's how I learned it. So then I go back and say, okay, what was the equation? It was Q equals mCp delta T. At this point, it just depends how you like to do math. Okay? Do you like to plug in the numbers and then solve for what you don't have, or do you like to rearrange the equation and then plug in the numbers and solve for what you don't have? I like to rearrange. So I'm going to rearrange it, but if you like to math by just plugging the numbers in and then solving, that's okay. Okay, I'm not saying one way is right or wrong. So I'm going to say CP here. I'm going to solve for CP. CP is right here. So I'm going to divide both sides by mass times delta T. So I'll get Q divided by mass times delta T. Everybody okay with that? See how I got it? Then I just plug in.
Ms. Howell?
Yes?
I need PE Lucino to come to the attendant's office for a few minutes.
Okay.
Thank you.
All right, so then we're going to plug in. So we put Q, 181 joules, divided by mass, 38.8 grams, times by change in temperature, 11.0 degrees Celsius. Now remember, when I'm putting into my calculator, I'm going to times the top, or put in the top, then I'm going to hit divide, put the bottom in parentheses, and then hit equal. So if you don't have a calculator, come get one. If you have one, get it out. We're going to be using it a lot today. Okay, when somebody gets the answer, go ahead and let me know. We'll want 3 significant figures. 3 significant figures, because that's what we have in all of our data that's been given. So 3 significant figures. What do we get? There's a lot of units and none of them canceled out, so we got to keep them all. So the unit over here, at the very end, would be joules divided by grams times degrees Celsius. So I keep all the units. Nothing canceled. 3 sig figs. 424, and I heard that repeated by more than one person. So do I have a second and a third? Okay, so this is our specific heat. Most often specific heat will be point something, so that will help you so you know that you got it right or wrong. If you end up with a big number for specific heat, you did something wrong. Okay? Big number for specific heat would be water specific heat, which is 4.184. That's a large number for specific heat. Okay? So it should be a small number. Anybody have any problems calculating? You're going to be doing a lot of this in your assignment. You might be solving for CP. You might be solving for mass. You might be solving for an initial or final temperature. If you do, solve for delta T first, and then add or subtract to get what you need. Okay? Because remember, delta T is just temperature final minus temperature initial. So if you find delta T, then you've got to have either the final or the initial, and you're just looking for the other one. Okay? All right, so let's go on to here. We're going to go into that's the end of notes for today. Not much to remember. That equation is very important, though. So if you have a hard time remembering equation, take that note packet with you when you go back into lab. Okay, we are going to do the pre-lab. If you stay with me, you'll have the pre-lab done when you go back into lab, and I can just go around and stamp it. If you go duh and space off, you will not have it done. Okay, I'm going to walk you through what we're going to do when we go back to lab. So when we go back to lab, we are going to first up and foremost, first thing that we need to do. I'm going to pause. We're going to do what we need to do when we go back in the lab. Okay, you and whoever's sitting on your table are your lab partnerships. The little person that's on your desk should be the lab area that you're going to. Okay? Yeah. Okay, so the little person in yellow, that's the lab station that you're headed to. When you get to that lab station, you should have a stirring hot plate or a hot plate. You want to turn that hot plate on to high as it will go. That's the first thing. Oh, besides that, get your goggles. Turn it on to high. Make sure it's plugged in. Okay, because I had kids last period that turned it on to high, but it wasn't plugged in. It won't work unless it's plugged in. Okay? All right, so that's a good thing. Once you get that plugged into high, second thing that you're going to do, actually third because you got your glasses, is you're going to get a beaker. There should be a beaker of water close by if your station's been used before. You want to grab the 600 milliliter beaker, and you want to make sure it's filled with distilled water to the 500 milliliter point. Okay? Now, the distilled water, if you need extra distilled water, is in 2 liter or 3 liter containers back there, or milk jugs. That's our fancy equipment. Okay? Then the rest of it you can just do slow, but that needs to be done fast because it'll take most of the period to heat it up. Okay? Next, what you're going to do is there should be a little white box. It's between you and another lab station. In that box, there are 5 different specific heat metals. Okay, there is aluminum, it's a tall one. Copper, you guys know the color of copper, right? Then there are 3 other metals, and these are the ones that the kids always get mixed up. So there is one that is sort of a gold silver, that's tin. There's one that is a blue silver, that's zinc. And there's one that's a silver silver, and that's steel. Okay, so silver, silver is still. Gold one is tin. Gold, silver is tin, and blue, silver is zinc. So your partnership needs to pick two. I don't care which ones. The other partnership needs to pick two. Here's a hint. The tall one might not be a good choice. You might have a very large experimental error. Okay? So don't pick the tall one. Okay, now, once you do that, you're going to take your two and you're going to put it on a scale and you're going to weigh them. So you pick two and you're weighing them. And you're going to put your information on the grid on the next page. Okay, then you are going to, they're like little cylinders, and on the top of the cylinder there's a little knobby. You're going to pick that up with some triangle tongs. And if you don't have triangle tongs, come see me, because you want to use triangle tongs straight down, just on that little knobby. And that's important, because you're going to put them in with your tongs, your triangle tongs, that are holding the little knobby on that cylinder, and you're going to carefully put it into your water so that they're standing up. Okay? You want to get them in there as quick as you can, because you want them to heat up with the water. That's what we want to happen. We want to heat it up with the water. Okay? So at this point, then it's sort of casual. You're going to come over here, you're going to grab a styrofoam cup, and you're going to weigh the styrofoam cup. I should put another color. You're going to weigh the styrofoam cup. Okay? Then you're going to add to that 100 milliliters of distilled water. And then you're going to weigh the cup again. Well, why don't I just put it on and do tare? Because we've been having problems with some of our balances with tare. So don't use tare. Okay, so weigh the cup, put the water in, weigh it again. Take the difference to get the amount of water. It should be about 100 grams. If you've done it right, it should be about 100 grams. Then you're going to take that and put it in a beaker so it doesn't tip over. You're going to grab a temperature probe. You're going to hook it to an easy link that's hooked to a calculator. This is our fancy thermometer. Okay? When you plug, and you're going to put them in that order, take the temperature probe, plug it into the easy link, then plug it into the calculator. When you do that, it should bring up the screen and give you a temperature reading. It should be about 20 degrees. If it's 200 and something, something's wrong. Okay? So it should be about 20 degrees. Then you can go ahead and put the temperature probe in here carefully so that the wire does not get onto the hot plate. Okay? And you can just let it go. It should boil about 96, so you can keep an eye on it and see about where your temperature is. You want it to be a rolling boil. When it gets to a nice rolling boil and you've got a steady temperature here, about 96, and it's because the storm's coming in, it might be a little bit less or a little bit more. You want to write that down as your boiling temperature. So everybody look at the grid on the second page for me. It's on the back of the first page. Okay. Numbers 2 through 5 for both samples 1 and 2 will be the same. So 2 through 5 for samples 1 and 2 will be the same. So you're just writing boom, 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 boom. Okay? Once I get that done, then I'm going to take this thermometer out. I'm going to run it under cold water from the faucet to bring it back down to the temperature it was before, about 20 degrees. Okay? Then I'm going to put it in here. So my temperature probe now is in here. I'm going to get the initial temperature for sample 1. So this is going to be number 6 for sample 1. Everybody following me? Because this gets a little tricky right here. It goes really fast, but you got to know what you're doing. So that's number 6 on column number 1. Okay? Then you're going to take and you're going to move the first sample, whatever is in your column 1, over here, and you're going to stir the thermometer and get the highest temperature. That's number 7 on column 1. Number 7 on column 1 and number 6 on column 2 are going to be the same, because you're going to not take that metal out in between. Okay? Then you're going to move your second metal over here, and you're going to get the highest temperature for number 7 here. At that point, you're done. You just need to clean up, get it set back to where it was. It's hot water on here. Just, you're going to take the tongs that look like this, that have rubber on them right here and here, and you're going to lift that down and put it on the countertop, okay, with those tongs.
So we put it on the hot plate in the beaker?
No, you're going to take the beaker off the hot plate and put it on the countertop. Okay? These right here, once you get to the end, will be cold. Will be cold enough that you can just take the styrofoam cup, dump the water out in the sink, grab the metals, dry them off, and put them away. Okay? Get a stamp when you get cleaned up. Then you come back in. While you're waiting, though, work on assignment 4. So once you're here and you're waiting for it to get up to boiling, you're working on assignment 4. Like I said, more than half the kids finished assignment 4 before they left back there. I have put that MCP Delta T on the far whiteboard in there so you can go and look at them if you need to. Any questions? Okay, go to your station goggles and let's get going.